Ladies and gentlemen, I want to welcome you to the 201st Earth2Class program. We're pleased to welcome back our good friend Margie Turrin. And Margie is, I think, the education director. I'm not certain what the exact title is.
You're going to elevate me. Director of Educational Field Programs at Lamont. Cassie's the educational director.
And I've worked with Margie for over 20 years, maybe 30 years now, since I was doing something with Kim Castens one summer. But we're very pleased to welcome Margie to tell us about some of the recent work she's been doing with Lamont scientists on Greenland Rising. Just before I do that, I just want to point out on the Earth2Class screen. Okay, we're going to have more information available for you on the Earth2Class website down here under February 6th, Greenland Rising. And I want to thank Christiana for recording this, and when she finishes the recording and edits it, it'll be posted along with the other Earth2Class YouTubes, which are available here. From a couple of weeks ago, we have a two-part, because we had some tech issues with Ajit on the 200th workshop, and we have Suzanne Straub's programs about trans-Mexican volcanoes. And over here we have Lynn Sykes' program about nuclear test ban treaties. We also have a couple of programs I've done at various conferences. This is one on connecting scientists, teachers, and researchers. This was done with two of my college students, Camille and Journey. Always pleased to be able to work with them, and I think they'll be on a little bit later.
I'm here.
Okay, good. You awake? You're ahead of me if you're awake. All right, let me get back into my screen here. Okay.
Okay, terrific. Well, thank you, Mike. And I'm going to go ahead and launch into today's talk, which is about a program that we have underway right now called Greenland Rising. And you'll see a variety of different names down here on the bottom. These are colleagues from GINR, the Greenland Institute of Natural Resources, who's our partner with Lamont Doherty in this particular project. And the names that you see are people that have helped with putting together just the education component of this project. So this is a co-production project, which means that we are working in partnership with Greenlandic communities to actually do this work, which I think is really important. And I think it's a wave of the future in terms of trying to do things more collaboratively rather than a kind of what's been more of a traditional approach of US scientists or scientists from other places kind of parachuting into some of these locations, doing work and leaving, and not really working with the local knowledge and the understandings that exist in the communities. So this is our logo, which is a beautiful logo, and this is from Greenland's flag. This is their symbol. And you can see that we're very much focused on the marine environment. We have a ship involved, and we're kind of going to go through that now and show you how all these things tie together. So this is a project that's funded under NSF's Navigating the New Arctic program, which is very much focused on co-production. So they really are interested in partnerships and not having science just done in these locations, but done together. And they have three different pieces that they would like you to hit. One is focusing on the natural environment. One is providing something that's useful back to the community, and then working with the community. And so for us, that meant focusing on Greenland Rising, which is changes on the coastline in Greenland, looking at the natural environment. So what are the effects on the natural environment? And then what are the effects on the ports and the coastal infrastructure? And then what are the effects on people's use and work on the waterfront? And I want to do a quick detour right now to say that we've been working together for over a year. And just this last week, it was brought to my attention that there is no word for waterfront in Greenland, in Greenlandic. So we were doing some translations of our materials, and waterfront is something that we use very regularly. It's in a lot of our materials, and they went all the way to their minister to find out what's the translation of waterfront, and came back and said, well, it depends if you're talking winter or summer. We don't know how to translate that. So we're learning. I think that's the bottom line in this, is that it's all new and different, and trying to work together with different communities and different international partners is always going to be an opportunity for learning for all of us. So I also want to point out that there are 4 different communities that we're focusing on. And I apologize that I'm not able to say the names the way that a Greenlandic individual would be able to say them, but this is Gushoshwak, Asiat, Nuk, and Tasilak. And for today, what I would like to do is actually assign everybody a community that you're going to be tracking, because I think we want to be looking at this through the eyes of these different members, because that's what this is all about. It's them learning a little bit more about their community. So I don't know what people's birthdays are, but I thought this might be a good way to divide this up. So if you were born January to March, you're going to be from Kusorshwak today, and you're going to be looking at it through that community. If you are born April through June, you're going to be focusing on Asiat and focusing on changes there. If you were born July through September, you're going to be from Nuk, and you're going to be thinking about what's happening in Nuk. And October through November, you're going to be from Tasilak. So I guess I just want to find out if we have people from every community before we go forward. So I wonder if you could just pop in the chat if in fact where are you from? So what is it that you're going to be identifying with today?
Okay, Margie,
Yes.
Camille has asked a question. What about December birthdays?
Oh, did I not include December?
Right. We'll
Oh,
include
I meant
Tasilak.
December in Tasilak. Sorry, I can't do math apparently.
We'll do a Tasilak.
Right. So we have several Nook. Oh, so thank you. Those of you who are in December picked Tasilak, so that's great. So we have Kushorshwak. Oh, do we have anybody? Oh, yay, we have everybody. Okay, terrific. That is what I wanted to know. Okay, so you guys are focusing. Don't forget, these are your communities, okay? And apologize for not knowing my my calendar well enough. All right. So going forward, again, this was a partnership and a co-production component, and this was from our meeting January of 2020. It was the first time we'd actually been together, although we had started as a partner in September of the prior year, so 2019. And it was such a big event that the Minister of Greenlandic Affairs, this gentleman here, Sung Chau, who actually is stationed in Denmark, was over and came to our inaugural meeting just to kind of wish us all well. So that was kind of fun and exciting for everyone. And just a really interesting opportunity to be in their space and also actually be in the community. And what it afforded us was an opportunity to see the facilities that they have. So they have this amazing vessel, which is called the Sana, which is what we're using to do our mapping, our deep mapping. And then they also, at the time, actually, we were working with this one different group, which is Asiak, not Asiat, but Asiak, with a couple of these partners back here. They were ultimately had to pull out, but they had the little dinghy that was going to do the shoreline mapping. So now we're having to look for a different boat for that. But all things will happen and we'll get it resolved.
So that's your summer
just to
picture?
show you. Yeah, sorry.
That's your summer picture?
Yeah, exactly. So this was from January. And then this is a picture that they provided, obviously. I didn't take this. But this is just showing the capabilities of doing the multi-beam data collection, which is something that they did during the last season. They did in one small part of one community. One of the things we're learning through this project is that it takes a lot longer to do any of what we want to do. There's a lot of weather delays, there's a transit, there's, every equipment breakage, you know what it's like. So plans have been set back a little bit. Of course, then we had COVID on top of everything. So it's been an interesting project, but amazing in that we've been able to move forward in large part because we've had some pretty good partners. In fact, incredible partners. Otherwise, we'd be nowhere. So one of the cool things that happened while we were in Nook in last January was that they have this event annually called Culture Night, where they open up the town, the village, and people kind of travel around and see different things. And so GINR, who was our host, you can see this wonderful narwhal hanging from the ceiling. It's an incredible facility. But anyway, they hosted one of the stopping points. And so that particular night, they gave us like a front and center a set of tables so that we could really talk about the project, because a big part of this project is gathering input from the community. So helping us to understand what are their needs and their interests, as well as us trying to explain what we were trying to provide back in terms of a product. And in that particular night, we had over 1,700 community members come through, which was incredible because Nook's population is about 18,000. So that's about 10% of the population. Traveled through, had some ideas for us, lots of thoughts on where we should be looking. Obviously, we aren't able to just do everything. So of course, a lot of that was trying to discuss expectations and what are the opportunities, but there was a lot of wonderful feedback and everybody was extremely excited. Language in Nook is a little easier than in some of the other communities. There's a lot more English, but just to provide a little context, in Greenland, the further north you go, it's pretty much all Greenlandic that's spoken. There are Danish members throughout Greenland. There are about 56,000 people that live in Greenland. And certainly a fair portion of those are either Danish or intermarried between Danish and Greenlandic. But further north you go, as I said, more Greenlandic is spoken. As you come further south, there is Danish, Greenlandic, and then in some of the larger places like Nook, there's more English. So it was nice for us to be able to start there because we were able to kind of get our feet under us, if you look at it that way. So once we hit March, of course, we were unable to go back. We had planned 4 visits in 2020 to go back to work in communities. We were unable to do any of those. So that meant that we really shifted our emphasis and our efforts towards our Greenlandic partners. And so you can see literally this is a fully Greenlandic ship going out. You know, all the data was collected by them. David over here on the far right of the screen is Australian, but he works at GINR. But I think everybody else was Greenlandic in that picture, which is amazing. It's really kind of neat. And 2 of these individuals, oops, let me go back. Nina and Jane were students that were picked up as part of this who are Greenlandic master students. So it was really nice to have that opportunity for them to learn multi-beam and be able to be part of the survey. We also, a major part of this was community meetings. So to try and gather what were the needs or interests of the communities and what we were going to be able to do. And this is an example of a meeting in Nook where Akaluk and Carl, who are from GINR, were meeting with municipality representatives. And again, because of COVID, these meetings were designed to be community meetings with, you know, like our culture night with 100 people or more, just kind of sharing ideas and having them with the schools. So we would bring in parents and families and really get a good turnout. They ended up being very different, 1-on-1, 3-on-1, you know, very small groups, which as Akaluk says, you know, that might be a better way to get information from people. If you have these big events, they often don't show up. So it could be that this was really an opportunity for us. Whatever it is, it's what it was. So the idea was bring in some maps and let's talk around the maps and see where the areas of interest are. This is Aasiaat. So those of you who are from Aasiaat, representing Aasiaat, here you are. We have about 3,000 residents in this particular community, so much different than the 18,000 in Nook. And as you move to the last 2 communities, even smaller. But all of our communities are waterfront communities. So they're all coastal villages. They make their living off of the water the marine interface. And, it's a very small kind of spread out walkable towns. Again, here's the waterfront, just to kind of give you a sense. So laying the groundwork for you. And they live and work literally right on the waterfront. So again, just kind of putting that into our minds, why this is such an important project for them.
Where are the kayaks?
There are sailboats, there are some kayaks, but mainly they work on the water. So these are little working boats. They're off fishing and, hunting. Yeah, it's a little different than our life, Mike. And then again, so the meeting in Nook was primarily with municipalities and different government groups. When you get away further north and into Asiat, Shorshwak, these other areas, you're going to meet more with the hunters and fishermen to hear what their interests are in the mapping. So this was Akaluk, who's in the middle, meeting with the hunting fishing group. It's a very child-friendly and focused society, by the way. Everybody comes with their children to meetings, which is why we wanted to host these community meetings in the school when we were talking about having these meetings. But again, we weren't able to do that. And Rose, kayaking between ice blocks? Yeah. Okay. Again, I just wanted to point out the neat opportunity that was made available because we were focusing totally on local participants to really run this. They brought in graduate students who were really looking for an opportunity to do, what we would call an internship, I guess, where they got this working experience. And Nini is from Asiat, so it was really cool because she was able to kind of communicate back with the town or the village, I guess we would call it, and really help to introduce the project in the village. She got on the local radio with Akaluk. They talked about it, which was really kind of fun, very, very interesting. A large part of our project is about, it has an education arm. So it's about delivering back to the schools with educational material. And I'm going to spend most of my time talking about the educational material and kind of letting you guys dig into it and see, what are the interesting pieces of it. But what it meant for us was that we were zooming into the classroom, and Akaluk and Marina and Carl were actually in the classroom. So that's why this was a really intense collaboration. We started with what we call a lighthouse teacher. So a strong teacher who is helping us with vetting materials. She works in the international school, which is a little bit more English strong. So we're able to actually do a better job of curating the materials, and then Marina can translate them and is translating them for use in other communities like Asiat, where we're going in the following 2 weeks. And again, just kind of fun, you have these opportunities for students to talk about uplift and different things. And we missed this, but Marina was documenting it for us. So we got a chance to see how this resonated with the students and that they were actually interacting with the material and kind of thinking it through, which was just what we wanted. We wanted them to actually have the opportunity to kind of dig into it and really work it through. Another kind of fun thing that we decided to do was, because very few Greenlandic students go on to what we call high school, and on to college. We wanted to showcase our Greenlandic partners and that we're working in STEM and show career opportunities. So this is Akaluk. And one of the fun things about Akaluk was he was a professional wrestler and decided to go back to school and become a geophysicist. So it's a really, an opportunity to resonate with the youth in Greenland who see no real interest in STEM. He can tell them, hey, I tried something else, and this is what I found out. I had a good time, but then I realized I couldn't support my family and I wanted to go and do this other thing. So again, just kind of these neat, and of course this is all in Greenlandic, so if you're trying to work your way through what it says, forget it. But it talks a little bit about their career path and their opportunities. And Marina is from a very small village, actually by Asiat. She didn't even go, they didn't have a school in her community. So they call it a family school, I think they call it. I'm sorry, Marina, I'm probably butchering that if you're listening in the ethosphere, but her mother was a teacher, and there were about 6 or 7 village members or settlement, I guess they're called settlement members who came and studied. And she was so excited about the opportunity to go. So in Greenland, if you decide to go on to college, you actually are supported financially. So she got to study in Finland, which was amazing for her. And she's a huge advocate of helping other Greenlandic youth learn about these opportunities. And then I mentioned Nini is from Asiat. So this is a way of showing a local resident who now is getting her master's in geology and geophysics. So very cool. Okay, so when we go into the schools, we start by saying that this is a partnership with the schools, which is true. The schools are actually helping us with data collection, and that is, I think, a really important piece for them. We want them to understand what they're collecting, what it means, and then have them actually working with the data just to build their own STEM literacy. So the students are collecting, we're putting in tide gauges, local kind of community tide gauges. We also have some higher end ones that we're using to better understand the changes. But the students are collecting tide data, coastal observations for us, and helping us record the changes on the waterfront. And then, as I mentioned already, the communities are helping us identify areas of study. So the project is called Greenland Rising for a reason. Greenland is actually seeing the opposite effect of sea level that we are. So instead of in our area where sea level is rising, in their area, sea level is actually falling in many areas, in most of the around the coastal areas. So not all of it's happening the same way. This is why everybody is going to be focusing on a different location to kind of help us tick through this. But it's because of changes in the ice weight and mass that these things are happening in Greenland. So it's a combination of the weight of the ice, which weighs down the land, and the mass of the ice, which has this gravitational attraction, is creating these changes. So first we'll kind of tick into the ice weight and how that affects local levels in Greenland. This is Greenland, by the way, Kalilat Nanat. So this is the way we're used to looking at Greenland. It's kind of a satellite image, and you can just see this incredible thick ice cover. But if we were to pull that off, you can see that the land looks very different under the ice. So where do you guys see that the land has been pushed down the most?
Towards the north.
Say it again?
Towards the north.
Towards the north? So up
Our
here?
ice is thickest.
Ah, how do you know the ice is thickest there? I didn't show you that.
No, you didn't, because glaciers tend
Smarty
to be
pants.
highest at the center and they flow outward.
So yeah, of course you're absolutely right, but we're working with students who don't have that understanding, and so so what we really want them to do is actually dig in and look at the map. And so, this is a great opportunity to dig into a map key and kind of get them thinking about what's really going on. And of course, the thing that a lot of students will focus on is the fact that it looks as if there's a lake in the middle of Greenland. And so this is an opportunity to talk about the fact that this is a color bar that's looking at elevation. We're not looking at water. So we're looking at what are the elevations or depths. And so this blue color that's in the middle here is actually showing us a negative number. So we're below sea level. Next we could go into where the ice is the thickest. So where do we think the ice is the thickest? And why do you think the coast is not pushed down as much as some other areas? And, a lot of times when I introduce this whole concept of the weight of the ice, I'll talk about the fact that Greenland, to me, is kind of, if you pull the ice off, it's kind of like a crown where the center is just empty almost. And then you have these high areas around the edges. So it's kind of like this large bowl or crown. So if we wanted to look at ice thickness, we could pop on a different map. And of course, then you can see, just as we heard, the ice is the thickest in the middle. So that does relate to the fact that it's just weighting down the land in the center. And if you move all the way out to the edges, it's close to having no ice on it, although in many areas, the ice actually extends all the way to the coastline. So why do we think the coast isn't pushed down as much? Go back to the weight, right? So the whole idea. So this is just trying to reinforce the idea that this weight is critically important. And as you change the weight of the ice, you're going to be changing everything. So one of the things that is, I think, important for them to understand is that where you push down, if you, and I know you all know this from geology, but where you're pushing down, of course, you have this soft interior layer that's not as rigid, and so it's going to give. And then you get these bulge areas on the sides, right? And what's of importance is to note that those bulge areas actually happen outside of Greenland. So it's not as if the center's pushed down and the edges of Greenland, those mountains, are actually pushed up in response. All of it was covered in ice. So those bulge areas are off the edges, which means then as you relieve the ice on top of these coastal edges, they are going to be coming back up. So this is a little bit different. I know for a lot of us, we think about the US and how the ice sheet sat on the northern part, but the bulge was in some of the southern parts of the US. In fact, here we're going to see that subsidence ultimately offshore. And time is always an interesting thing to try and discuss with students. Well, with all of us, time is really hard to kind of put our heads around. But this is a super slow and long process. It's going to be happening over hundreds to thousands of years. And so we aren't going to see this immediate adjustment of the land surface. But we are starting to see it. So if you guys can see that area and you can think about what community you're from. And so just a reminder, this is Kushoshwak for those of you who are there. This is Asyat, this is Nuk, and this is Tasilak. So looking at these different images, do you think you'd be able to see the impact on your own community? And you can just unmute yourself, we can have a conversation. So do you think you'd be able to see this? Now, this is in millimeters a year of uplift. What do you guys think?
Not Nook.
Not in Nook, okay. Yep, pretty small, 6 to 10 millimeters. How about any of the others?
No.
No?
I mean, if this is in millimeters a year, then in 1 year you might, but over the course of maybe a few decades, you might be able to.
Okay, great, absolutely. I think I 100% agree with you. I think, you know, millimeters is such a minimal adjustment that unless you're like right on the edges, even over a decade or so, you probably wouldn't be able to feel this or see this. So this is why, you know, there's almost like a hidden component. It's adjusting, but it's really hard to tell. So this is over a period of 14 years. This is from 2006 to 2020. Do you think the motion's all going the same direction? So what are we seeing here? Any of your communities doing anything different? So you can see all these images are going up, right? So this goes back to the idea that all of this had ice on it, and therefore it's all adjusting up at this point as we start to lose some of this ice. So which of your communities do you think had the biggest impact? Who's in a community that thinks got really has had the strongest impact?
Well, if I were there, I'd say January because I can't pronounce the name.
Absolutely, the K word, right? Oh dear. Yeah, and ASEAN seems to be pretty close as well, right? So it does seem as if we're kind of this direction. Although interesting, right? That the other side seems to be, we'll get to that actually. The other side in the north seems to be behaving a little bit differently. So I added another layer on this particular map. So this is the same set of arrows. And now we've put a little bit of accumulation data on the ice sheet. And so what you can see here is that, and by the way, in Greenland, they don't call it an ice sheet. They call it inland ice. So if I say inland ice, I'm talking about the ice sheet. So you can see in some of your communities, you're having a different effect than other communities in terms of ice accumulation. So this is in meters a year. So not millimeters, we're talking meters a year. And the red is areas where we're seeing meters of ice loss. And you can see up to 2 meters of ice loss in some of these areas. So this is close to the Aasiaat area. This is actually Ilulissat, which or Jakobshavn, some of you might know it as. This is an area that's rapidly changing. And then there are some areas where you're actually seeing a little bit of gain, right? Up to 2 meters of gain. So how's the land elevation in the Northeast comparing to the Northwest? And anybody gotten a hypothesis for what might be happening there? So here's
There
our,
seems to be some kind of an imbalance in the amount of ice.
yeah, absolutely. So once you add in this ice sheet melt, you're going to see changes going on. So it does seem as if there is some kind of a correlation, which is right, something that's of interest to pay attention to.
Margie, does any of this relate to ocean currents and weather?
Ah, interesting. That's where we're going next. So good job. Way to predict. And he hasn't seen this slideshow. So yeah, it's probably has to do with how we have different ocean waters up on the continental shelf on different sides of Greenland, and how that's relating to this melt and accumulation. So again, the whole idea here is to try and get them thinking about the whole system and how these things actually relate together. So things that are happening on the land are connected to things that are happening in the ocean. Things that are happening on the ice sheet have to do with things that are happening on the land underneath. So it's kind of a nice way of tying it all together. Okay, so that was ice weight. Now we're going to talk about changes in ice mass and how that affects local sea level through gravity. And this is gravity is something that's very unfamiliar to the students in that we'll be working with. So it's kind of this attraction between these matters, and we try and identify that early on for them. So what's the difference between A and B? Who wants to tackle this for us? You kind of describe what's going on here. Anybody?
Do I see that ice mass is a way of indicating the volume of ice?
Yeah, so ice mass is its volume and its density. So the full amount of the mass, yes, of the ice, sorry. Yes. And so between A and B, what do you see happening with that ice sheet mass?
So in A, you have a much larger gravitational attraction of the ice mass than you do in B.
Yeah, so you can, and you see that in the way that, you know, we've tried to depict this water being kind of pulled towards the ice, which is something that's not intuitive. You know, the idea that the ice actually has mass like a mountain would have a mass and would be attracting water to it. And as that mass is reduced, that water level drops off, and it doesn't just drop down, it actually has a negative effect where it drops lower and that water moves away. And that happens in the short term. So, and I should, the short term is is actually an odd way of saying it, but that will adjust ultimately through time. So where's the source of the gravitational attraction in A? It's the ice mass. And what about in B? This is a trick question, but it's still that ice mass. It's just that it's been reduced. And so you see that water being pulled away. So it's just a way of kind of framing in the brain that the ice actually attracts water to it. Oops. Okay, so this gravity is kind of, it's just what I just said. We'll keep moving. So this is an image to just kind of depict what's going on right now. And right now, this is shown in millimeters a year. And so you see around Greenland, there is actually already we're seeing a loss in that gravitational attraction at millimeters a year. And those are moving to other parts of the ocean. So you can see this a little bit darker bulge down here by South America, the Marshall Islands. There are areas that are being affected the most. And they call this a fingerprinting effect of the ice sheets. So the ice sheets have fingerprints, and we've seen in prior times, there's a history of this in areas around the world from when we have had ice sheets and lost ice sheets in the past. So what do you think? Do you think millimeters of loss, does it matter at all? Do you think a millimeter of adjustment has any impact?
It's in places like the Marshall Islands, it may have an impact.
Yeah, and I think that's a really important thing to for us to pay attention to. That, you know, those of us that are in the Hudson, we think about having this wonderful palisade sill, and we have these big barriers that help protect us from some of these smaller changes in sea level. But as somebody mentioned earlier, these accumulate. So it's not as if it's just one time and then next year we'll have a millimeter, but it won't be accumulating. It is accumulating, and it is having an effect in some areas already. We're seeing it. And just to kind of put it in perspective, the global annual average is 3 millimeters of sea level rise a year. So this is, in fact, a piece of that, a pretty recognizable piece of that. So something to just think about how these things all tie together. Okay, so what's causing this ice sheet to change? And I'm sorry, I'm having a hard time paying attention to the chat. So maybe I'll take a minute and say, so there are a couple of things that are written in here, and I don't know if they're recent or if not. So would ocean currents or weather patterns affect this? Was that related to when we were talking about the Northeast, Northwest?
Yes.
Okay, perfect.
Yeah.
And
I had said it just
Marion
before.
has a question now.
okay, perfect. Sorry. And you know, guys, just feel free to pop in because I can't multitask so well when I'm trying to do this. So how do you distinguish ice loss at Greenland from that in Antarctica? Oh, excellent question. And I'm sorry I didn't include that slide in here, but I do have slides that show that. So in fact, for us, the impact is from West Antarctica. So there are there's a whole body of scientific study on this, and a couple of people that have looked a lot at this are Mo Ramo and Jackie Osterman. And so I don't want to step in to try and explain the science because I would probably butcher it, but I do know, excuse me, I do have maps they're actually in our Sea Level Rise app if you wanted to go there. Excuse me, into our Sea Level Rise app that show as you lose ice in West Antarctica, the effect is almost the opposite. So it's almost like it's a far field effect and a near field effect. In the near field, you see a drop. In the far field, you see a big rise. For us, West Antarctica is hitting our coastal regions. We do see an effect from Greenland. There are very few places that don't. You'll see this little rim of white is the only one that really doesn't, but it's not anywhere near as dramatic as Antarctica.
Margie, we have another question asking whether the rotation of the Earth has an effect.
In terms of the rotation of the Earth has an effect on the on exactly what? Sorry.
Ask that. You, Ruben, can you unmute and ask it?
Yeah. On any changes of the ice sheet, is the rotation of the Earth impacting the fact that either east or west going to lose more ice or the other way around?
Yeah. I guess I don't know the answer to that, so I would hesitate to step into it. I doubt it, but I don't know definitively, and so I'm gonna say that I couldn't answer that for you. I'm sorry. Okay, So what's causing the ice to change? So I know Mike already mentioned the fact that we're seeing ocean warming. And so a lot of these currents are actually tracking a little bit warmer water than we've seen in the past. And so that can have an effect on what's going on and where we're being affected around Greenland. This West Greenland current coming up here is tracking warmer water up. And this ice is actually closer to the continental shelf where the ice itself is sitting. Here, the continental shelf is right up against it, but the ice is tracked back just a little bit, so it's not seeing the same effect. And it's been warming, since the end of the last ice age. So for the last 12,000 years in this particular area, we've been seeing this warming going on. And so you have ocean currents, but then a equal, if not stronger effect is this weather change. So the Arctic is warming much faster than the rest of the world, twice as fast on an average. But if you look at just winters, it's 5 times faster what's going on in the Arctic. And it has to do with a number of reasons. There's more land mass in the north, so that's helping to hold that temperature. Antarctica, this area is much more isolated. But loss of sea ice is another major factor. So as we've lost sea ice, we've opened up this very dark color in the ocean, which is much more absorptive than the reflective white sea ice. And so we're really seeing these big effects occurring, which is obviously affecting what's going on in Greenland, as well as Alaska and Canada, other areas in the Arctic. So let's take a peek at this map. So what do you think those different lines represent if we were to kind of look at this map? I don't know if you guys can see this well, by the way. Can you see it well?
Yeah, I think so.
Make everybody squint.
It suggests the coastlines at various points in the past.
So, okay. So the extent of the ice sheet. And I think I would go with, ice extent rather than coastlines, because not necessarily where the coastline is, but where we would see the edge of the ice. And an interesting thing, if you look at this, so have you guys had Nicholas Young talk in this group, Mike?
No.
Okay, so this is from some work that Nicholas has done over a whole range of different projects. But these are, again, representing different timestamps. And if you look at 12,000 years ago, when I said we started to really see this warming in Greenland, other parts of the world saw the warming a little bit earlier than that. This is where the ice extent was. And then at 10,000, it dropped to this yellow line. And then at 9,000, it dropped to this orange line. And then at 8,000, it dropped to this blue line. And then at 6,000, it's here. So that in itself is kind of an interesting piece, in that we had this mid-Holocene warming that actually took us back further than we are now. And we had an additional ice extent occur. So currently we're on this red path, and you can see that in this lower area where we see those of you who are from Nuuk and those of you who are from Asyut have seen the ice further in and then re-extend. We haven't seen that for those of you who are in our K-town, and for those of you who are in Tasiilaq. Again, we really haven't seen that really big retreat. So interesting, right? Okay, so I mentioned to you that we were putting tide gauges out to help us understand the rate and amount of sea level change. So let's kind of dive into that a little bit. So this is a map that's looking at long-term tide gauges from around the world. And what do you take away from this? Like, what are some observations? Thinking about it from your own community now. You guys have your 4 communities.
Much better mapped in many of the more affluent parts of the world.
Not much attention to Iceland for historic reasons, I suppose. There wasn't a lot of settlement there.
it looks like there are a lot of these gauges closer to the east side of Greenland, whether it be in northern, I guess that's Northern Europe, like Scandinavia, as opposed to the west side. There are some in the west side, but they're, I guess, farther south in the US and Canada. So we may not have as complete a data set for the west. I mean, that could impact the west side data.
Yeah, absolutely. You guys are right on the money. So we don't really have a whole lot of data. In fact, we have none of these in Greenland, right? No long-term tide gauge data from Greenland, which will make it very challenging for us to try and really understand what's going on those coastlines. So that is one reason why we wanted to get in there and put in some tide gauges. Now, it doesn't mean there haven't been tide gauges there. There have been a few, but they aren't long-term, and they some of them were put in for just a period of time to get some data. Some have had strong interruptions. So there's 2 years of data perhaps, and then a big break and maybe another year of data. So we'll look at actually what does exist from Greenland, but in terms of having a long-term tide gauge, we don't have one. So that is a big puzzle for us, and one of the reasons that we're very interested in getting some of this data. And so why we're interested in this is that these tide gauges help us with doing predictions. They help us with showing what's been going on, getting trends together, and that helps us really understand where we might, excuse me, be seeing things go in the future. So I mentioned that there have been tide gauges. I love this picture. It's amazing, right? So this is from 1926, and you can see, you know, this incredible effort to just get a tide gauge in. This is only temporary, so it's a lot of effort to get a little bit of data. You can see, you know, they have this measuring line here. I mean, this is really a great historic data. We look at our Greenlandic helpers here, just amazing. And this is from Conic, which is further north than our K-town. So way up on top, and it does not exist any longer. It was a short-term data set. All right, so there are a few tide gauges that have been in for a few years, and you can see the dates on these. So the one that's in Thule, which is the Conic area, which is just north of our K-town, that's been in since 2004. I cannot pronounce this, I'm so sorry to say. This is 2008. Nook is from 1960. Oh, not bad. And then Kutortak, which is from 2008. So we don't have any in Tasilak. We don't have any in Asyut. So comparing these changes, are they all going the same direction?
Would you know whether any of this had to do with political friction between Denmark and Greenland?
Do I know what? I'm sorry, I missed the first
Whether
part.
any of the lack of tide gauges had to do with political friction between Denmark and Greenland?
No, I don't think so. I don't think so at all. I mean, there are different ways of interpreting that friction, and I would hate to get into it too much because it would be me interpreting from different people. And yes, while there's a strong interest in the Greenlandic people being in charge of their own country, and there are lots of internal strife and politics, Denmark has gone in and aggressively looked at science and done science where they feel that it's needed. So I wouldn't say that that's part of this.
Okay, thank you.
Yeah, no problem. So what do you guys think? Are all the changes going in the same direction?
No, Nook's the oddball
Nook's the oddball. Okay, why do you think that is?
because it's rising.
Well, it is rising, but why do you think it's behaving differently? Do you think of anything that we might have seen that might suggest why it might be different?
Mike points out that Nook has a longer data set.
So Nook does have a longer data set. I love it. That's a really interesting hypothesis. What else?
And you can't tell, I'm not a pro on looking at the maps here, but it looks like Nook has I don't know if fjords are the best words, but it looks like the coast is a little more shaped than compared to the other uh, uh, locations.
I love that observation. I think that's amazing. Um, and you know what? I don't think we know all the answers, so it's great. I mean, these are great things to just kind of pop out and talk about. I wondered if anybody would go to those the ice lines of the past and the retreat, and perhaps the fact that this area might have seen retreat earlier and had more ice retreat through the last 12,000 years. And maybe that is meaning that, excuse me, it's gone through an adjustment period and is now seeing a different effect. Who knows? I mean, there are lots of things that could be at play, but this is why we're interested in this, is to try and understand all the different variations. Excuse me. So what can tide gauges tell us? And again, this is just trying to bring back to the students the idea that these tide gauges are ways of really looking at change through time. So developing trends and better understandings. So we are installing these smaller tide gauges around the edges of Greenland. This is Akaluk and Nini and colleagues putting in one in Aasiaat over the summer. Unfortunately, it was broken off by either ice or by a ship that docked. We're not sure. So this one's no longer there, but we are not deterred. We're going to go back and put in an additional one. And that's actually kind of fun because the students get to help put it in. So in Nook, the students did put the tide gauge in. This is Akaluk out with the student group that we were working with. They did some planning as to how to launch it. Akaluk was in the classroom with them, helping them think it through. And then they went out and installed it. And it was a rather blustery day. Very, very cold from what I understand. But they're a resilient little group and they did it. And as these students are putting out the tide gauges, one of the reasons that we'd love for them to do it is we want them to understand how deep it is, how it was put in, so that they can help us with understanding what metadata is and how it's important for them to record all these different variables so that we understand when we're looking at one tide gauge compared to another, what are some of the differences? What's the depth it's set at, et cetera. And just so you know, we had some challenges because we don't know this area. So we were trying to, even Akaluk, we haven't put these tide gauges out. So kind of thinking about how deep they needed to go and all of these things was a learning experience for us as well. And just to kind of give you a sense of how friendly this area is for the students to go out and check and work in, it's a daunting environment, but they are just so resilient. There's one picture that we had of them going out to collect data, and I couldn't find it quickly, but it's just like the whole thing is ice covered. There's not much that they could really do or observe when they were out there. So aside from collecting the actual tide data, they're doing these observations of the waterfront of the coastline so that we can get a sense of what uses the coastline, what kinds of birds and fish or mammals and people, how it's being used.
You may already, or you may get to this a little bit later, but did the elders in the community have any stories about how the coastline used to be in different places?
Yeah, so that's an interesting piece that, yes, they did. So those small meetings are great for that because you do get that kind of commentary or feedback. When they were in Aasiaat, I know there was a conversation with one of them where they were very excited to hear that Greenland was rising because they had noticed it, but they weren't sure what they were seeing. So to them, hearing that, oh, the reason that we're seeing this rock kind of emerge from the water is because it is emerging from the water because sea level is falling. So, that piece really worked well. We have also developed we haven't done it yet. We're working to develop an interview set of questions for the students to go out and talk with their parents. How that's been challenging for us because our choice of words and questions, this was where the waterfront piece came in. We had written a lot of them around waterfront and they were like, we don't know what you're talking about. So we're trying to work that out still. But we think it would be a really neat piece. And there is a part in their curriculum that's about understanding Greenland from the Greenlandic. And so really having that opportunity to talk to their family members as an assignment seemed like a really wonderful way to go, way to go forward. So in terms of what they're actually collecting for while they're at the waterfront, they're collecting weather data, storm data, all these different, looking at predictions versus actual. And I'm going to spend just a minute going through with you why. So why we try and explain to them, what does this mean? Why are we asking you to collect all this data? So weather, why does weather have anything to do with it? We want them to understand that weather highs and lows, which relate to sunny and cloudy kind of stormy conditions, actually has something to do with water level. And so this is a great opportunity for them to be doing something in the field that actually relates to an Earth process that they can now start to understand just a little bit better. And then the whole idea of weather events, not just plain old weather, but how these events can actually have an effect. So looking at the mean sea level and normal expected, so astronomical tides versus storm surge. So recording if there was a storm, if we're in a storm, or something's approaching, how that will affect their tidal regions. And then just kind of showing them examples in the data of a weather event. So this is actually from our area. This is showing a storm, New York. You can see that this rather large change because of the storm. And this is in feet. So you can see that there's a pretty significant impact from this particular storm event. And then you can actually see it in what occurred. And I'm sure you guys are probably aware of what storm this might have been. So this would have been Sandy, just really showing us these kind of what you can physically see versus what's going actually on in the data. And then using the same example to look at actual versus predicted, and why it's so important to not just use predicted tide readings, but actually to go to an actual. So there are some predicted levels that are out by the Danish Meteorological Institute in these areas, but we want them to actually collect the data itself. So looking at the amplitude range between high and low and predicted. And so in this particular situation, it's a few feet versus, what actually happens when we have a storm surge and this much more significant amplitude. And then moon phases. So how do moon phases affect things? So again, this is a great way of tying together for them how these differences between these lowest lows and these highest highs relate. And so, what phases of the moon actually relate to this? And getting them to look at these different examples between new moon, full moon, and these, the spring and the neap tides, just gets them thinking about, oh, it's important for us to pay attention to these variables when we're actually out looking at the waterfront and collecting this data. Okay, so let's dig into some actual data. First of all, we want to just start by identifying the axes in this. So it's kind of small, so I'll help you. These little green triangles are actually the Danish Meteorological Institute, their charts, so their predictions. The red is the actual Danish Meteorological Institute gauge. So there is a permanent gauge in Nuuk that's been there, as we saw, since 1960, was it? So it's been in for a bit, although we'll show you that there's a few hiccups in things. So it's not as if we can rest on our laurels. And then the blue is the new gauge that we put in. So now that you've seen that, let's get some questions going. So what's the general tidal amplitude in Nuuk?
Looks like it's about 6 feet or 6 meters.
Yeah, so first thing is meters, right? So this is a much different environment than the one that we were looking at. So the fact that we're going from these highs to lows, and it absolutely is about 6 meters on average. Okay, so what's the same between these three different measurements? These three different, shouldn't have said gauges, but these three different measurements.
General patterns.
Yeah, so you can see that there are highs and lows in both, right? That seem to follow a general pattern. What's different?
Well, they're out of phase a little bit, which is interesting, and consistently out.
Yeah, so that's great. So you see a pattern in the differences right there, right? So they're consistently out of phase, absolutely. And what do you think that might be from? And this is really just troubleshooting, to be honest.
I'm wondering whether the fact that Greenland is so much farther north compared to where the moon is directly overhead would have any effect.
Hmm.
And maybe that could drive currents.
Okay, so I went exactly where you guys went, and it was actually something that was a lot more simple than that, to be honest. It was because they were set up on two different time zones. So when we put ours in, it was one time zone, and the DMI had theirs in another. So we had to do this adjustment. So you'll see this onset with a 2+ hour adjustment, and that allowed them then to overlap a little bit better. So again, this is great though for students, right? To recognize that, you know, you set these things in, you go away, and then you realize later, oh geez, one is on, you know, GMT time and one is on West Greenlandic time. So we had to adjust for that. But it was a great thought process for them, right? Okay, so just looking at this, can you make a couple of observations? Are there a couple of things that you can pick out? Just simple observations, nothing, you know, major.
Well, when you add 2 hours to the onset, it seems to like now match.
Okay, right? So we seem to be able to actually get that. Okay, we'll keep going, and we'll see, you know, what turns up. So I'm going to just point out there's a bit of an amplitude difference between the DMI data and our onset data, right? Seems to be a little bit different, and it seems to be correlated with one part of the tidal cycle. You guys see that? This was another learning opportunity for us. So we didn't actually know how much the tide was going to change or how related to how deep it sat. So in fact, it wasn't set deep enough. So it was drying out at low tide. And so we weren't getting the full tidal cycle. So again, you know, these are pieces of practical that are an important part of the science that we were able to, the students were part of this whole thing, and they had to try and tease this apart and come up with, hey, what the heck did we do wrong? And, you know, it was great because Akaluk, who helped them set the tide gauge, was like, hey, guess what? We screwed up. You know, we didn't do this right. So again, it's like sometimes it's just knowing that scientists make mistakes or that there are things that we don't know is very useful for kind of helping the students through this. Okay, so, you know, what can we learn from the data? Is just collecting a little bit of data really an important thing? Is there anything we can learn from it? And we actually did. So we learned 3 things. We saw 3 different processes just from this little snippet of data. We saw that the Greenland Western time versus the GMT time. So there was an offset. So that was important for us to learn. We saw that the gauge was drying out. Again, we learned something from that. We learned about how deeply we had to sit this to make it useful. And then we learned that the predicted was off in a lot of instances. So that it's important to actually have our own data versus just relying on the predicted. So again, you know, just with a couple of days of data, we were able to actually show for them some really interesting pieces of information that they could capture and hold on to. And then we actually looked at a longer period of data and looked at the variation over this 5-day period and, you know, what might be driving that, allowing us to tie that back into the lunar cycle. So all this was really important. And then we actually downloaded some data and let them graph it in Excel, which we obviously won't do today, but that in itself was a very interesting opportunity. So one thing I wanted to mention is that they're looking at actual quantifiable data. They're also looking at qualitative data. So they're doing a variety of different things and they're documenting. So they're taking photographs and drawing pictures while they're there. Again, using multiple ways of collecting data, which reinforce and build on each other and are all critically important, which we think is really helping them to understand how they can, number one, how science is done, how it's important to have these different methods of data collection, and the value of each one of them. So this is one of the students' coastal diaries, and this is a picture that they took for us.
Did you guys do a seasonal variation in the tides? Like spring versus fall versus summer versus winter, or was it just limited to this specific time period where you're showing us data?
Yeah, that's a great question, Adam. So no, we had intended to do a full season, but we ran into a problem. So the fact that all the things that can go wrong do go wrong, right? But that's okay. We're there for another year and we'll correct this. But remember that we set the tide gauge at the wrong elevation. Then Akuluk got sick and was unable to go out and correct it in the field. Then he had field work with another project, so he was unable to go out and reset it. And ultimately, the winter freeze came very early and froze it in place. So it's so frozen right now, we can't get it out. We need a pretty good melt to be able to reset it. Ultimately, we want to set it deeply enough so that we can get it year round, because we are interested in that. Such a great question.
Tom here, the slide that shows the changes in global warming, relative changes in global warming, had a blue area down there in Antarctica. What's causing that particular area to close? And I don't remember. I didn't see a number on the slide.
We don't remember what slide we're talking about, but in terms of,
it's one that shows the whole world.
Oh, sure. Okay.
Yeah.
So, so part of what's going on in Antarctica is the fact that there's the ozone hole. And the ozone hole is actually related to driving the winds in a certain pattern. And so there is a very strong hypothesis that the ozone hole is actually helping to accumulate snow in a specific area, rather than, you know, where we expect to see melt, we're actually seeing accumulation. There have been a couple of papers that were written on it by a gentleman at NASA who made quite a bit about it. And that's been much in the conversation of polar scientists, because, you know, Antarctica is huge. It's 1.5 times the size of the US. If you went to certain parts of any country, you're going to see variances in what's going on. So in the US, there are areas where we're seeing more accumulation than we would see melt in the winter, right? We're seeing more snow than perhaps we might have seen in other times. So I think that it's probably not wise to draw big conclusions from variations in snowfall in certain areas, just to be honest. But it has been linked most often to the ozone hole, which is a kind of an interesting thing, right? Because we think of the ozone hole as being a warming thing, but it definitely has changed the winds. Okay. So what can tide gauges tell us about sea level? So now let's just take a peek at long-term data. So I mentioned to you that we have this data from, so these are all on the same time scale. So this is 1960 to 2020. So 1960 to, oops, so something just got in my way here, to 2000, we had this nice data set, but then that tide gauge stopped working. So bummer. We have some data, 40 years of data, which is very nice. Okay, so then we can go to satellite data. And satellite data, we can kick in from 1990 up to 2020. Then we have the new DMI data coming in. So that came in not that long ago, but 2015. So for 5 years, we've had that. So we can cobble all this together to try and put together a long-term data set. And so it's nice that we do have these different methods of being able to look at things. And Dave put them all together for us on one graph, which was amazing. And that allowed us to look at trends. And so this is for Nook. So those of you who are in Nook, our trends are telling us that it's 1.76 millimeters a year that we have seen this sea level go up. Interesting, right? Okay. What do you think? Do you think this will continue to go up? Those of you who are from Nook, what do you guys think?
I would think so. As more ice melts, etc.
Okay, so the expectation is that it will. Trends do change, as we can see in this graph, but the expectation is that in the long haul, we're probably looking at this a continued trend.
Tom here, if you go back to the previous slide, it appears that the
This
one
one?
before that, it appears
Okay.
that there is quite a differential among the three different graphs where they intersect. Why are they so different? You see what I'm asking?
Yeah, so you're looking at, so there's a big difference here where those two go over each other.
Bingo.
And there's also a big difference here where these two go over each other. So this is from satellite data. And these are actually from tide gauges that are sitting in the water. I am not an expert on this, so I
Your
guess
satellite
I
data
don't know.
gathering information over a larger area. How pinpointed is the data for the satellite?
Yeah, it's actually supposed to be very pinpointed. So it is supposed to be a pretty high resolution. So I guess I don't know. I can't answer that for you. What I can tell you is that when, so Dave Porter put all this together for us, and this is an area where he does a lot of work. And he was able to pull together all that with the trend line. So I don't want to make a comment that I can't back up. So I don't know, Tom. I'm sorry.
Thank you.
No problem. Okay, so if we were to look at Nook's trend line, and it's at a little less than 2 millimeters a year, and look at what's going on in other areas in terms of changes around the coastline. What do you think? Do you think if you had data for Asiat, do you think it would be doing the same thing as its kind of counterpart on the other side of Greenland?
Probably not.
Probably not. Okay. And I think that that's kind of where we're going with this, is that we really need many more of these. If we really want to understand conclusively what's going on around all these different areas of Greenland's coastline, we're going to need a lot more data. So one of the things that we have talked about is that they have teacher programs where they bring them into the university in Nook and do some education. And we were hoping that we might be able to actually hand out tide gauges and get them installed in these different communities so that we could get additional data.
Margie, how much does a tide gauge cost?
Well, they're not, it depends on the type of gauge, but they're not outrageous, a couple of thousand. So they're not outrageous, but we are hoping that we might be able to find that. Trouble that we're having right now is that with changes in the way we're doing things, the way that we have budgeted this project is being adjusted very differently, as you can imagine. So
One reason I'm asking is whether there are also Rotary clubs up there.
Oh, in Greenland?
Yes.
No, there are community, like municipalities and things, but yeah, there's really not much in the way of a business. A lot of independent kind of operations. There's a Passow Source Walk, which is like a little kind of community. So one store in a community that literally does everything. There's a sea market that does collect fish from local fishermen, but there's not a whole lot. It's a pretty rural environment.
Okay, thank you.
Yeah, of course. Okay, so again, just a reminder that we're looking at changes in both ice weight as well as ice mass around Greenland. And now we're going to look at the land in Greenland. So we saw that from tide gauges, sea level was going up. Now we're looking at the land in Nook. And what are we seeing here?
Upward pattern.
Yep, so it's also popping up, right? So we can see that we have a trend in the uplift of the land at almost 5 millimeters a year. And we have a trend in sea level of almost 2 millimeters a year. So you can see that you have a pretty noticeable impact in Nook as to what's going on in terms of actually their coastline change. Okay, so let's go to those of you who are in Thule. Oh, sorry, you're not in Thule. You're in the K world, Kushorswak. So let's just look at Thule because that's the closest data we have. In here, you can see that the land motion is almost 8.5 millimeters a year. So pretty noticeable. And that the sea level is falling at almost 17 millimeters a year. So what percent of the change in sea level is the land motion? I wonder why there's this big block there. I'm gonna have to go into my chat here.
Oh, it was just me. I was just wondering what that white block was.
I think it's it needs to go away. It's I think it's just a text box that got kind of shifted into the wrong place. So it's not, there is continuous data there. So it's about half, right? So it's an interesting kind of phenomenon that they are working in opposition to each other. So if we just kind of go back to your own communities, each of you has a community. So if you could look at your own, these are estimates for what we expect to happen by 2100 based on what we know now. But again, we're learning a lot more as we go through. So in the Kushorswak community, the expectation is that sea level will fall by almost 3 meters. So 2.7 meters, that's a lot. In Asiat, the expectation is that it'll be about a half a meter, a little over a half a meter. In Tasilak, it is 1 1/3 meters, so pretty significant. And then you see that Nook is the anomaly. So Nook is an area that the expectation is that we will actually see it rising, which is interesting. And again, it's an important kind of piece that every community is going to be affected differently, and we need to be capturing these measurements in all these different places. So in addition to actually doing this work with the students, we're also going to be looking at how the coastal habitats have been changing. So that's the piece that Laurel, who's on here, is working with me on, that we're hoping to roll out soon. And then we're also going to be talking, as I mentioned, to members, have the students talk to members of their family so that they can record these changes. This is Magnus, who was worked with us in 2014 up in Kushorswak. Lovely guy who spoke about 5 words of English and was incredible at communicating without having to talk. He and his cousin were out in a little fishing boat with us collecting some measurements. Gabriel spoke no English. Magnus said, oh yeah, he could talk. And it was mainly kafala. Do you want some coffee? Amazing. Okay, so that is actually what I have. And I hope you enjoyed learning a little bit about it. I can stop sharing.
Okay, please unmute yourself if you have some questions for Margie. Margie, thank you for another fantastic program.
You're welcome. It's a wonderful program because it's so different. It's
Thank
just
you,
got
Mike.
such a wonderful element to it. Yeah.
Okay, so for everybody's information, Christiana is going to edit this and we'll post it on the Earth2Class YouTube channel. And the easiest way to get to that is go to the Earth2Class homepage, and there's a link from the top on the homepage. Margie, I'll send you some emails about the possibility of getting some of those data so that we
Yeah,
can
you
have
can
people do activities.
You can absolutely. So we have these PowerPoints developed. They're actually in a series of 3 right now that we're using in the communities. One that's an introduction to the project, one that's about tide gauges and the weight and the mass of the ice sheet, and then the third is about kind of unpacking the data. So I kind of squished them together a little bit. But you absolutely, I can make those available to you. That's what they're there for. And I think they might be interesting for your students because they're so very different from what's going on in our part of the world. So, the idea that things are not always the same is something that I think we don't think about a lot.
That's part of the problem for our American political system.
Yeah.
One part of the country thinks everything in the country is the same as what they have there.
Yeah. No, absolutely. It's just a great opportunity for students to recognize the very different worlds people live in, but also the impacts of those worlds.
But to quote Wally Broker, I'm right. Okay, everybody, thank you very much. Any other questions?
Nice to see all of you.
Good seeing you, Tom.
Thank you.
Stay cool.
Okay. Send rain.
Bye, everybody.
Bye, everyone. I'm closing up now.